Okay, welcome to our latest SPHN webinar series here. Today we have two expert panelists, Dr. Sally Dickerson from UC Irvine and Dr. David Almeida from Penn State. They're both leading experts in the field of psychosocial research using cortisol assessments, so we're very lucky to hear from them today. Before I turn it over to Sally, though, I just want to orient our attendees to the panel on the right here. So your presenter panel should show a section that says questions, and you can just click in that box and go ahead and type out a question. If that doesn't work for you, there's also the chat option. You can either send a chat message to the entire audience, just to me, or to our panelists there, but I will be fielding the questions, so please make sure that I can see them. I just realized I didn't introduce myself here. My name shows up as Kate Sweeney as the organizer, but those of you who know Kate or me know that this is not her voice. So I am Megan Robbins. I'm at UC Riverside here, and without further ado, I'm going to turn it over to Sally.
Great. Thank you so much for the invitation, Megan, and I am looking forward to talking about cortisol studies with all of you. So I'm going to kick things off today with a little bit of an introduction about why you might want to look at cortisol and, in the context of social personality research, and then talk a little bit more specifically about some of the methods that if you're for incorporating cortisol into laboratory-based studies. And then Dave and I are tag teaming, and I'll turn it over to him to talk a little bit more about more naturally occurring studies after that. So I have a lot of information that I want to try to get through, so apologies if I'm moving quickly. I'm happy to also make my slides available afterwards, so don't feel like you have to write everything down as I'm going through the material. But I wanted to start with a few practical reasons why you might want to incorporate cortisol into social personality research. And the first is that cortisol is a health-relevant physiological parameter. And so one advantage to incorporating cortisol into your research is that it can allow you to examine mechanisms through which social psychological processes may ultimately influence health. So it can bring this health dimension to your work. Also, there can be dysregulation of cortisol in the context of some psychological disorders like depression or anxiety. And so cortisol may be relevant to those of you with more clinically oriented interests. And cortisol can be easier to assess than some other types of biomarkers because you can easily collect saliva samples in which you can look at cortisol levels. And so compared to other biomarkers that may require blood draws or other types of kind of costly or invasive procedures, cortisol can be a little bit more straightforward. And I think incorporating cortisol into your research can also open up other opportunities for additional funding sources. So those are a few of the practical reasons. I think there are also some important theoretical reasons for why you might want to look at cortisol. One of them is that I think that stress can be construed quite broadly and is really applicable to a number of topics that may be of interest to personality and social psychologists. So, for example, you might kind of think about processes like discrimination or prejudice or stigma as a type of stressor, and therefore stress-related physiological parameters may be important to look at in this context. I think that incorporating cortisol can also be useful in order to allow kind of a full range of outcomes, in order to look at a full range of outcomes that might be affected by the social psychological process that you're interested in. So just as you would look at multiple outcomes like perhaps emotion, behavioral outcomes, you can also include physiological parameters to kind of look at a whole host of different processes that that may be related to your topic. I also think that another interesting way to consider cortisol and other biomarkers is that sometimes you see interesting dissociations between physiological responses and self-report measures. So you might see a lack of concordance between emotional and physiological responses, for example. And I think that these situations are not only interesting, but having this additional component of the physiological or cortisol assessment can give you some additional information about the underlying process that you're interested in. So those are some reasons that social and personality researchers may be interested in incorporating cortisol. But I think the flip side of this question is also relevant, and that social personality psychologists can contribute a lot to the literature on cortisol and stress reactivity. So social and personality psychologists bring a great deal of methodology and theory, assessment of individual differences and emotion. And so I think that bringing these kind of skills and interests to the table allows social and personality psychology researchers to really carve out an important and distinct program of research within the stress reactivity literature. So those are some potential benefits to incorporating cortisol, but there can also be some challenges with this as well. I think one really important thing and a big takeaway, hopefully from today, is that you can't just kind of add on cortisol to existing protocols. You really need to think through about incorporating cortisol assessment at all phases of the design of your study. Another thing to consider is that cortisol assessment can come with some expenses. So if you're assessing, if you're taking saliva samples, you may need a freezer to store the samples, and then money to run the assays in order to determine the cortisol levels. And so there is some expense involved. And another thing that can be somewhat challenging is that oftentimes you want to think about participant restrictions, so inclusion or exclusion criteria for the participants that you bring into the lab or are studying in order to make sure your data is interpretable. So those are a few of the challenges that you need to kind of think through when moving into the cortisol world. So I'm going to move now into talking a little bit about some of the mechanics of running a laboratory study with cortisol assessment. And I'm going to be drawing on two kind of sources. First is a meta-analysis that I conducted with Margaret Kemeny looking at acute stressors and cortisol responses. So I'll be drawing from some of the findings from that, as well as a chapter that I contributed to a methods book on social psychophysiology that talks about cortisol assessment. So these can serve as further resources and additional information as well. So if you are thinking about running a study with cortisol, there's sort of some typical components and things to think about when doing this. So typically you would have participants come into the lab, and then there would be a baseline period in which they kind of habituate to the experimental setting. Then they would go through a stressor or some other type of task, and then you can assess cortisol levels post-stressor, and you can look at reactivity, which is sort of the peak change or that maximal increase in cortisol over baseline values. And you can also look at recovery, or the time that it takes for cortisol levels to return to baseline following the stressor. So the baseline period, the stressor period, and then the recovery period are all things to think about when designing cortisol reactivity studies. So I'm going to go through three main categories of considerations. One category is methodological. Another category has to do with participants, so things like inclusion and exclusion criteria, and then also choosing an appropriate task when looking at cortisol reactivity. So we'll go through each of these in order. So in terms of the first methodological consideration that I want to discuss is the time of day in which you run your study. So the image here shows cortisol levels over the course of the day. And as you can see, you have this sharp increase in cortisol upon awakening, and then a pretty significant decline in the morning hours. levels kind of flatten off in the afternoon and evening. And so this diurnal curve then that you see with cortisol has implications for when you run studies looking at cortisol reactivity. If you can imagine that if you run a stress reactivity study at 9 a.m., you're really kind of fighting this steep cortisol decline. And so it might be more difficult to see stress-induced increases compared to if you ran the study later in the day when levels are relatively flatter. And so diurnal rhythm is something to consider. And not surprisingly, this is data from the meta-analysis that I mentioned showing the difference in cortisol reactivity in terms of effect sizes of studies that took place in the afternoon versus the morning. And as you can see, the studies in the afternoon were associated with larger increases in cortisol compared to those in the morning. And again, this is because of this diurnal cortisol rhythm. So what can you do in order to kind of address this diurnal rhythm? Well, one way you could do this is by conducting a within subjects design. So participants on one day could come into the lab and rest while cortisol samples are taken at specific intervals, and then have them come in on another day and go through a stressor or specific task. And that would allow you to then compare the typical diurnal rhythm on one day to another day in which you have a stressor kind of overlaid on top of it. But of course, this type of within subjects design would be difficult and somewhat time-consuming. So another option would be to run all of your participants in the afternoon in order to control for this diurnal rhythm. This is the option that we usually use in my lab, and run all of the studies in the afternoon, or at least run them all at the same time of day to control for this diurnal rhythm. If that isn't possible for whatever reason, at a bare minimum, you'd want to at least assess, make sure that you take good notes in terms of the time of day that the session is run, and collect data on the time since the participant woke up in the morning, and you can use this as a covariate. So time of day is an important methodological consideration. Another one is the timing of assessment. So when you're actually going to take the saliva samples or blood samples that you would use to determine levels of cortisol. And cortisol is released as part of a hormone cascade. And so it can take time to actually see elevations in cortisol as the result of a stressor or some sort of stimulus. And in fact, your cortisol levels right now are actually reflecting what happened maybe more like 30 minutes ago instead of what's happening right now. And so this has a big implication then for running cortisol studies, since you don't see these increases instantaneously. And so the first thing that this can affect is the baseline rest period. So I mentioned before that oftentimes you'd have a baseline time where participants can sit quietly, filling out questionnaires or reading magazines before you actually put them through the task or stressor. And this baseline sample is really important. You want a quality baseline sample and that reflects true resting values and isn't maybe elevated because the participant was running late and just kind of sprinted across the campus in order to reach the lab. And getting a good baseline sample is important also because then it provides a benchmark to compare your reactivity and recovery values. And so it's important to try to make this a true representation of resting levels. So to do this, we usually have participants go through about a 40-minute rest period when they come into the lab in order to have the kind of level for the participants to habituate to the experimental setting. And we did find that the length of the rest period does predict cortisol reactivity, suggesting that a longer rest period may be a good thing to do in order to make sure that you can elicit a cortisol response. So getting a quality baseline sample that is one thing that you want to think about. Another thing is the timing of when you are going to assess cortisol post-stressor, or after you put people through a specific task, when do you take your saliva samples or blood samples? And what we found, again, this is data from the meta-analysis, that cortisol responses peak approximately 21 to 40 minutes after stressor onset. So if you're interested in measuring this kind of peak cortisol response, you'd want to be sure and get at least a sample or two within this 21 to 40-minute window. Now, if you're interested in looking at cortisol recovery processes, or when cortisol returns to baseline, what we found is that on average, the cortisol levels remain elevated up to 40 minutes post-stressor, and then return to baseline values after that. But so if you're interested in looking at recovery time, then assessing up to about an hour post-stressor would allow you to kind of chart these recovery trajectories. So what then would be an ideal number of samples to collect throughout the experimental procedure? So at a minimum, you'd need at least two, right? One to assess a baseline sample, and then another to assess the reactivity. But certainly, collecting more samples would allow for kind of finer-tuned analyses. And in my lab, we take 5 samples during the experimental procedures, a baseline sample, and then 4 post-test samples that are designed to capture peak reactivity as well as recovery processes. And of course, there's a trade-off here. It can cost more money to run the assays on more samples, but it does give you greater power to detect small differences. So this is particularly important, I think, if you're using a relatively subtle manipulation or expecting a relatively small effect size. Another trade-off, though, is that this can lead to long sessions. So if you do a 40-minute baseline period, let's say a 20-minute task, and then are keeping participants in the lab to look at recovery up to, an hour post-task, you're well over a 2-hour session, and so that's something to keep in mind. I want to turn now to talking a little bit about participant characteristics. And one thing that you want to kind of keep in mind when thinking about the characteristics of the participants you recruit is whether or not to assess certain characteristics that may influence cortisol reactivity or to exclude on these. So you certainly are going to want to assess your basic demographics, so things like age and gender. And these can be used as covariates in different analyses. With medical conditions, there may be some conditions in which you want to exclude. So cortisol is an endocrine hormone, so excluding participants who have endocrine disorders might be a good idea. You can also, you'd want to at least assess and potentially exclude on other conditions like psychiatric disorders, acute illness, and you'd also want to either exclude or assess certain medication usage. We exclude participants who are on steroid-based hormones or steroid-based medications, for example. There can also be other hormonal considerations to think about. So for your female participants, menstrual cycle can influence cortisol reactivity. And so you would want to either schedule the sessions accordingly or at least assess where your participants are in their menstrual cycle. We simply provide a calendar where participants can indicate when they started their last period in order to look at that. And oral contraceptives can blunt salivary cortisol responses. We exclude women on oral contraceptives from our studies, but you'd want to at least assess this if it's not feasible within the context of your study to exclude. Oh, and this is just a graph that illustrates the differences in menstrual cycle and oral contraceptive use. There are behavioral restrictions or considerations to keep in mind too. Smoking can have acute effects on the HPA axis, and so we exclude smokers, but you'd want to at least assess smoking activity if participants are smoking. Moderate to intense exercise can lead to increases in cortisol, and so you'd want to at least assess exercise that participants had engaged in that day, or perhaps restrict, ask them to not engage in strenuous exercise before coming in. Eating a major meal and caffeine can also increase cortisol, and so we ask our participants to not drink caffeine or eat a major meal for an hour before they come into the lab. And you can also ask them to not consume alcohol before they come into the lab. And sleep is also associated with different patterns of cortisol reactivity. And so you might want to include a questionnaire that assesses typical sleep patterns and also assess the time of awakening on the day of the experimental session to potentially use as covariates. So that is kind of a laundry list of things to think about when recruiting and participants for your cortisol reactivity studies. Another thing that's really important to think about is what tasks you're going to use. So what kind of stressor or other type of task are you going to pick in order to examine cortisol reactivity and recovery? And one thing that's really important to note is that not all tasks elicit cortisol to the same degree. There have been many different types of tasks that have been used in the literature, and some are much more effective than others. So this is data from the meta-analysis showing that on average, cognitive tasks, public speaking tasks, and public speaking cognitive combination tasks are can effectively elicit cortisol reactivity, whereas other types of procedures like noise exposure and emotion induction are less reliable in that regard. So picking a task that is capable of eliciting cortisol reactivity is an important thing to consider. But it's not necessarily just the type of task, but you can also look at characteristics of the task itself. So for example, we found that tasks that are relatively uncontrollable are more likely to generate or to elicit larger increases in cortisol compared to tasks that are more controllable. And we found that social evaluation, so for example, performing a speech in front of an audience, this is associated with larger cortisol responses compared to the tasks without. So social evaluation and uncontrollability then are two factors that you can think about when trying to choose a task to use in your studies. So social evaluation and uncontrollability both predicted independently, but where we really see the effect is in their combination. So tasks that had both uncontrollable and social evaluative elements were associated with much larger increases in cortisol than either component alone. So you might be asking, well, what task has uncontrollable and social evaluative elements? And a really good example of this is the Trier social stress test that's used pervasively in the stress reactivity literature. Excuse me. And so what the Trier social stress test, or TSST, is it is about a 15 to 20 minute stressor. Participants receive instructions and have a preparation period before giving a 5-minute speech, typically in front of 2 panelists and a video camera, and then engage in 5 minutes of mental arithmetic. So this is the basic procedure used with the Trier social stress test, but there's many different kind of modifications, and this can be modified in order to suit your research questions. And this is a picture of what it looks like when a participant is delivering the speech as part of the TSST. But of course, the TSST is not the only task out there. It is very commonly used, and it is a really effective means of eliciting cortisol, but it might not be appropriate for all research questions. So for example, in some cases, you might not need to elicit a cortisol response in everyone. So finding a task that kind of maximizes cortisol might not be your goal. One example of this would be if you were looking at individual differences. So one research example would be conflict discussion tasks with married couples. Not everybody shows increases in cortisol as a result of discussing a conflict, but couples that display hostile behaviors tend to show increases. And so that might be one type of, if you're interested in close relationships, it might be using this type of conflict discussion might be a good way to go. And, if you're interested in processes like ostracism or discrimination, trying to pick tasks that sort of tap into these phenomenon would be obviously relevant for your research. So I think the goal is to pick an appropriate task for the research question while also keeping in mind and considering the likelihood that you would be eliciting a cortisol response when, with any particular task. And so that was a whirlwind view of laboratory cortisol reactivity methodologies. And so I am going to turn things over to Dave and pull up his PowerPoint.
Okay, so Sally and Megan, I guess, can you hear me okay?
Yes.
Okay, great, good. So first of all, I want to thank Kate and Megan for inviting me to be part of this webinar. It's great to be part of the tag team with Sally, and I highly encourage anyone interested in cortisol to read all of Sally's work, especially the papers that she spoke of here. They're required reading for everyone who starts work with me. I think they're absolutely marvelous. And so, in fact, when I got into sort of the cortisol game, the Dickerson-Kimeny article is sort of my touchstone for everything. What I'm going to talk about today is using cortisol work in field research, so kind of taking cortisol work out into the wild and see if we can assess naturally occurring cortisol. There are several benefits of collecting cortisol in the lab that I've discovered when I try to do this in the wild, which is the ability to control the assessment and the collection of your bodily fluid that you're interested in. I use saliva, and I'm happy to answer any questions about, the best ways to get people to collect saliva well. But what I'm going to talk about mainly today is, basically give you a sort of a pep talk for considering collecting cortisol in field settings. Now, most of what we know about naturally occurring stress from surveys has used to rely on all self-report, both self-report of stressors that occur as well as stressor responses. And most stressor responses have asked people about physical symptoms that may have occurred because of stressors or psychological well-being. And this is pretty much what we had. In the past 2 decades now, there's been a push to try to assess physiological responses to naturally occurring stresses in the natural world. And cortisol, as Sally has delineated, is a really good marker of biological stress. I'd like to sort of point out in my frustrations of working with cortisol, I've had to understand and come to terms with the fact that cortisol has many purposes in our body. One is to alert us to stress and manage stress, but basically it's, if I understand the hormone correctly, it's primarily responsible for mobilizing energy. And so you need this in stress, but you also need it to get out of bed. You need it to digest food. And so I thought I was going to get a nice clean marker of stress, but really I have a marker of sort of energy mobilization. So I think this becomes important when you're looking at cortisol in the natural world, because that's really what you're looking at. So, still, I think it's the most popular and a very useful marker. It's a wonderful marker of the HPA axis, and it's also, as Sally mentioned, an important biological mediator of health. One reason why we can do all this work on cortisol now, both in the lab as well as in the field, of course, is methodological innovations in collecting cortisol as well as assaying cortisol. I'm not going to get into the assaying part. I'll talk a little bit about the collection. Then I'm also going to touch on, I won't go into much depth, but if you have any questions about this, I can send you a lot of information. The statistical modeling of cortisol. This is a hormone that's very dynamic. It is changing throughout the day, as Sally showed, but it's also changing from context to context. And this makes it a challenge to statistically model this. And I'll show you a little bit how we're trying to do this in our lab. I just tried to forward it. Sally, could you go to the next slide? Sitting there hitting my space bar. What's going on? What I'm going to do is give you some examples from the National Study of Daily Experiences. This is one of many projects that we're conducting now at Penn State and other places, trying to marry survey methodology, mainly telephone interviews, with biological collection of physiology. And so the National Daily Experiences is part of the MIDAS studies. I also want to mention that all the data that I talk about today are publicly available. You can download them in a couple clicks. And so if you're interested in this sort of stuff, I highly encourage you to sort of get into the data and see what it's about. The National Study of Daily Experiences is a longitudinal sample of just over 2,000 people where we did daily telephone interviews of these individuals every day for 8 consecutive days. This is one wave of the data set has 15,000 days. The entire data set has almost 30,000 days of information. It is what we would call a midlife sample, a fairly large age range from 3 to 4. Next slide. Next slide. Okay, thanks. The purpose of this research, and certainly of my research since I started doing this, is trying to understand daily experiences. And I hope this gives you a hint of why I'm interested in cortisol as well. As a psychologist, or as psychologists, we're typically interested in individuals, but I think we're also interested in other units of analysis. And so really I think of myself as someone who's really interested in understanding days rather than understanding individuals per se. And so in daily telephone interviews, we get a whole host of information, some of which are very pertinent to the behavioral assessments that Sally mentioned earlier. So we get a time use, and that includes amount of time people sleep, work, provide social support, good social support. We get information on daily physical health symptoms, substance use, medications that can be used as compounds for cortisol. We get positive, negative mood, work productivity, and then we have a lot of specific questions about the types of stressors that people experience, as well as positive events that people experience. The important thing to know about all of these classes of information is that the unit of analysis is the day, and so all responses have to do with what occurred in the past 24 hours. And we do this interview every day over a series of days to sort of try to chart the ebb and flow of all of these experiences. Next slide. If you hear me hitting my space key, that's what I'm trying to do.
It's a good cue. Thank you.
Okay, very good. So what I discovered, or what I have been discovering, is that you can find out a lot about a person's day not only in their self-reports, but also in their saliva. What we have people do is to collect saliva across 4 consecutive days on 4 times a day. So we get 16 samples of saliva, 4 a day on 4 consecutive days. We ask people to collect saliva at wake up, 30 minutes after wake up, before they have lunch, and then before they go to bed. Just as Sally mentioned, we try to get people not to have coffee or eat a big meal before any of these assessments. Okay, next slide. This slide is to show that do not be shy about trying this out. People will do this. So this is the first time I ever tried to collect cortisol, and I guess we really went after it in a big way. But of the 2,200 or of the just over 2,000 respondents we asked to provide saliva, around 86% agreed to do so, yielding almost 27,000 samples of saliva out of a possible 27,840. All of this is to say that people agree to do it, and when they do it, they're fairly compliant, and they give us usable samples. Okay, next slide. So this is an overview of the protocol. So we see that we have 8 days of diaries, and then on days 2 through 5 of the protocol, of the telephone interviews, we collect saliva 4 times a day. We chose this protocol because the first interview day, we get important information about what their days are like, but at the end of this interview, we give specific instructions on how to collect the saliva the next day. I should say before we even start the protocol, people receive what we call our spit kit. And so this is a little cardboard box that has all the salivettes for collection, as well as specific instructions there, as well as a DVD that I'm happy to share that gives specific instructions on how to collect your saliva. So they get this kit, and then we call them, then we give them instructions again on how to collect their saliva, and then on the next day they start collecting. On days 6 through 8, so the last set of interview days, the saliva collection protocol has ended, but this is a time for us to remind them to pack up their salivettes in a pre-addressed envelope and send them back to our lab. And so we found that this type of collection works really well for us in terms of instruction as well as getting stuff back. You should know that we never see our respondents face-to-face. All this collection happens, through the mail and through telephone instructions. Okay, next slide. Okay, so this is the reason why we get 4 times a day, and it's consistent with Sally's slide on the diurnal pattern of cortisol. She showed the entire 24 hours, and sort of this is what we're trying to capture within our estimates. And so one reason why we get cortisol at wakening as well as 30 minutes after wakening is to try to capture the cortisol awakening response. So as I mentioned, cortisol is this hormone responsible for energy mobilization, and so one reason why you're able to sort of get up in the morning and prepare for your day is that you get this surge of cortisol that gets you up and out of bed. And a healthy awakening response seems to be, this awakening response appears to be sort of a healthy profile. As the day progresses, we see that cortisol will decline throughout the day. We do not need as much energy as we sort of near our bedtime and get ready for recuperation. And so, so I would say a healthy cortisol pattern is one that would have this awakening response as well as this daily decline. And so this is my picture of sort of a healthy day. The 3 parameters that we get, some of the 3 we get more than this, but the important ones are the awakening response, the daily decline, as well as the area under the curve. So this is an estimate of how much circulating cortisol you would have within your system on a given day. Okay, so with this information, let's go to the next slide. Okay, so this is what we find. So these are real data. This is from the first 250 respondents in the National Study of Daily Experiences. I just had to see whether our cortisol protocols seem to be working. And in general, if you sort of stand back and squint at this figure, you see this very clear diurnal pattern with this sharp rise in the morning and then a decline throughout the day. But what you also see here is real life when you look at data, especially data collected in the field, which is a lot of variation. And so we have some people are having really steep awakening responses. Some people have flat awakening responses. Some people don't decline throughout the day. Some people have some increases throughout the day. So we see individual differences, but we also see intra-individual variation. So from day to day, people are varying in their cortisol patterns. So next slide. So what this forced us to think about is to try to decompose the variance in cortisol, decomposing it to sources that are between people, so this would be between person differences, So some people are less stressed than others. Okay, click. So that would be represented by, we see these differences from person to person to person. But what the cortisol is telling us is that there's variation within a person from day to day. So click again. And so here we see that even though we have people differ from each other, for a given person, there are some days that are better than other days. And so some days we have this nice healthy profile, other days we don't. If we go to the next slide, this is just a quick analysis looking at the amount of variation in area under the curve cortisol, comparing between versus within people. And what we've shown is that there's as much variation from person to person as there is within person across these days. And so what that tells us is that the diurnal pattern of cortisol is not one that is extremely stable. Rather, it is fluctuating, and it's probably fluctuating to conditions that are part of your physical as well as social environment, which as social psychologists should be exciting, I would think. So the challenge for us is to try to figure out what is accounting for both the between-person variation, why some people have more cortisol in their system than others, but also why would some days have higher levels of cortisol than others. So let's go to the next slide. And so one way to think about this is to consider variability across stressors. So this is one thing that we can get probably more easily in the field than in the lab. Probably could get in the lab. But I think one of the really exciting things that Sally introduced was how different types of tasks elicit different cortisol responses. I feel like I'm kind of doing this in the field, how different types of naturally occurring stressors will elicit different cortisol patterns compared to other stressors. And so one thing to consider is basically how stressors differ from each other. Okay, next slide. And so, so one thing to think about, we could divide different types of stressors. So we have an instrument called the Daily Inventory of Stressful Events that basically it attempts to create a taxonomy of daily stressors that people experience, and sort of the at the grossest level you can create a taxonomy based on broad levels of content. So some of our daily stressors involve interpersonal tensions, like having an argument with somebody or just being really angry at somebody but not arguing. Having overload stressors, basically having too many responsibilities at work as well as at home, as well as network stressors, stressors that really don't involve the participant but involve close friends or family members that where these experiences turn out to be stressful for the participant, like having a child who is sick, having a friend who's going through some relationship problems. Okay, next slide. And so here's a, again, I'm more than willing to share these slides as well. There's a very busy slide to show how we try to decompose cortisol into differences across events, as well as even within events there are differences. So you can imagine having an interpersonal tension, but it might be different having an interpersonal tension with a coworker versus someone who's a family member versus a stranger, something like that. So this is just an example of how we try to decompose not only variation in cortisol, but also decompose variation in the stressful experiences that people have. All right, next slide. All right, I'm really not going to go through these in detail, but this is how we use multi-level modeling to model the effect of stress, daily stressors on, in this case, AUC cortisol. And here's the simple analysis when we're looking at cortisol, where we'd have on a given day, your level of AUC cortisol is a function of an intercept plus what time you woke up. Timing is very important in assessing cortisol, plus the type of daily experience, the daily stressors you would have that day. Okay, next, click. And then so every single day you would run this model, and then you would see whether those days now vary across individuals. Okay, so let's go to the next slide. Okay, so this will bend your mind even more. If we're looking at the components of the rhythm. So the CAR is the cortisol awakening response, and DCS is the daily cortisol slope. Here we would use 3-level modeling. I won't go into this, but I'm happy to send papers and information about how to actually model this. But this is how we would do it. But let's get to the next. Let's get to the findings and show you what we have. Okay, so this is some analyses that we worked on for quite a bit, and what we found was that on days that people experience stressors, any stressors at all, they had higher levels of AUC cortisol compared to days that they didn't experience any stressors. And this was really driven by overt arguments with people, as well as being overloaded at home, as well as having network stressors. And so what this slide shows is that we can see almost, well, I don't want to say mimic what we have in the lab, but certainly parallel what we have in the lab. On days when people experience stressors, we see changes in their cortisol compared to days that they don't experience stressors. But it's driven by certain types of stressors, mainly stressors that involve other people and probably close other people. So here's some evidence for inter-event variability. And if we go to the next slide, this is another way of showing those results where on the blue line, those are network events, and the red line, those are interpersonal tensions. And we see that those are, on days that you have those, your cortisol curve looks flatter and has more circulating cortisol in your system compared to days, average days as well as overload days. Okay, next slide. If we look just at tensions, interpersonal tensions, it's not just having the tensions, but who you have them with that appears important. So if you have an interpersonal tension with a family member, you have higher levels of cortisol through your system compared to if you have tensions with non-family members. Okay, next slide. I think we're getting close. Okay, so I think this might be my last slide, but I want to sort of end with this. When conducting field studies, it allows you not only to look at naturally occurring stressors, but also event variability. That stress reactivity does not solely reflect stable dispositions, rather subjective appraisals and physiological reactions operate differently depending on the type of stressor and the level of analysis. And so, so if you're interested in assessing cortisol in the field, it's important to also have important consideration for what are the sort of the eliciting events and experiences that would be related to cortisol. And I think that's it. Is there anything else? Nope, that's it. Okay, so so it looks like Sally and I left time for questions. I know I talked really quickly, and staring at my computer, I have no idea if people are following this, but I welcome question.
Wonderful. Well, thank you so much, Sally and David. That was a wonderful presentation. So we have a few questions here, but I just want to remind our attendees that you still have the opportunity to ask more questions. So over on the panel on the right, there is a spot where you can pose a question, or you can also send me a question. You can, in the chat function there, you can send it just to the organizer, or you can send it to everyone if you're comfortable doing that. So you'll have some time here, so we have about 10 minutes for questions, so go ahead and feel free to submit those. But I'll go ahead and start then. So I think an interesting question here is to both of you, what is your sense of how much the lab and field study findings converge in terms of the types of stressors that elicit a cortisol response?
Yeah, well, this is, one of the $24,000 questions, probably more like a $1 million question if you're seeking funding for it. I think it's important to consider like the time windows of both of these analyses are very different. I think the laboratory studies do a wonderful job of trying to nail down the reactivity versus the recovery, like the reaction to the specific stressor. the type of work that I do, focusing on daily experiences, end-of-day diaries, the best that I can do is sort of characterize a day as sort of a stressful day versus a non-stressful day. And it's very difficult for me to tease apart what's the reactivity piece, what's the lack of recovery piece, and maybe even what's the anticipatory piece. We can try to identify when stressors happen, but I gave up trying to link a specific stressor to a specific cortisol response several years ago and kept my unit to the analysis. So in the MIDAS project, we do have laboratory assessments from the same participants who did my assessment. Unfortunately, the baseline assessments weren't that great, and so it's difficult for us to make real parallel assessments. But what I will say, and then I'll let Sally start, is if we just look at diurnal cortisol across all of the days, we do get some parallel findings, but they're really not that strong. They get a bit more similar if we look at the cortisol patterns on days when you have stressors. If you look at those patterns, they're similar to the reactivity pattern. So people who have a heightened diurnal pattern on a stressor day, those are the ones that are going to have slower recovery. That's about as much as we know right now.
Great. Sally, did you want to comment on that one?
I just think that the two different types have different advantages and disadvantages, and so having both types of methodologies in your toolbox, I think, is a really nice way to be able to kind of capitalize on the benefits of both types of methodologies. And I do think that so there are some consistent messages across the two, even the two types of methodologies. For example, in Dave's work and in the laboratory work, you see that social stressors, however defined, seem to be activators of cortisol and the HPA axis. And so I think that there are themes that cut across the laboratory and naturally more naturalistic studies that give us some indication that what is happening in the lab isn't such an artificial condition that we're not that we wouldn't be able to see similar patterns in real world settings.
Sure. Thank you. So our next question is about some of our SPH members' interest in patient populations. So Sally, you mentioned exclusions to consider, so think illnesses and medications. So for people interested in studying stress among patient populations, can cortisol be meaningfully assessed, and any sort of tips on that?
I think it absolutely can be meaningfully assessed. I think that it's important to have appropriate control samples or control participants in order to make those kinds of comparisons and see where there may be similarities or differences in terms of reactivity processes. And I think it would be important for whatever medical condition you are interested in to kind of dive in and see what types of treatments or medications would be appropriate to assess and potentially exclude on. I think that it's going to depend, it's going to vary from health condition to health condition and population to population exactly what those would be. But I would recommend, but I think that it can certainly give you some interesting information, either about how individuals with certain conditions may differ in terms of reactivity from healthy controls, or in terms of the individual differences within a patient population, how reactivity may relate to well-being or different sorts of health outcomes. So I think it certainly can be done. It just has to be done carefully in order to be able to reach the conclusions that you may want to reach at the end of the study.
That makes sense. David, did you want to comment on this one?
Just a quick comment. If you're interested, I think David Spiegel's work at Stanford has shown really interesting relationships between cancer recovery, cancer remission, and cortisol. So I think he sort of, at least from what I know, has some of the more interesting analysis on cortisol and health conditions, at least in terms of cancer.
Thank you. So another question is about the daily assessment of cortisol then. It's one that I get all the time with naturalistic studies. But do you get a sense of how much participants are altering their daily activities while they're doing the cortisol assessments?
One thing that we've looked at is whether all of our daily questions differ on cortisol assessment days versus non-assessment days, and we don't see any difference at all on anything, even wake-up time. I would say, for me, the most important thing to get, other than the saliva, is a best estimate of time as possible. And if you're not sure about when people collected the sample, then I would be very cautious of using it. It's just, there's such a strong diurnal pull in cortisol secretion that if you don't know really when people got the assessment, then it's difficult. And this makes it really difficult to get the cortisol awakening response naturalistically. Really making sure that people understand that they need to collect that first sample before they get out of bed is important. And so in our instructions, in our video, the vignette of someone collecting their cortisol while they're in bed, that sort of thing. So, but I don't think that the cortisol itself is altering how they spend their day. We do it 4 times a day. It's not like they're doing it 20 times a day. So, but who knows? It could be, I for one really need coffee right when I wake up, and having to wait 30 minutes, that would be an alteration of my day. So that would be the one where I would, a possible change.
Right, but you see maybe some convergence across their other measures on the days that they're not providing the cortisol assessments?
Yeah. So there's no difference of what time they wake up, when they go to bed. There's no difference in the stressors that they have, the positive events that they have. All of that is the same.
I think another thing to think about in the context of this question too is we try really hard to build rapport with the participants when we're giving them the instructions. And so we say things like, if you miss a sample, it's okay. This might happen, but just be sure, don't try to make it up, and make sure that you just then note clearly when you do take it to try to reduce those types of errors.
Well, thank you very much. That was all of our questions here today, but this was a phenomenal brown bag, so thank you again to Sally and David, and I hope to see you all at the SPH pre-conference at SPSP this month.
Great, thanks.
Thanks, and to those of you on the line, I'm happy to take questions via email if you have other follow-up questions or things come up.
Oh yes, and as a final note, I will say this session was recorded, so I'll be sending out the link as soon as possible, and then Sally and David mentioned they'd share their slides very generously, so we'll be sending those out as well. Thank you.
Great, thanks.
Thanks.